Now we could use other materials, but beech is extremely effective for a couple of reasons. One, because it's pretty freely available, but also because it's flexible, so it allows us to curve the construction pretty easily. What we're doing is we're building up multiple layers in opposing alternating grain structures, like you would do with an engineered wooden floor. So Jen, if you take an individual layer, if you take an individual layer, and you can feel it's pretty flexible, right? If I take that one again, it's doing the same thing. Put them alternating like this, you just immediately feel they start to stiffen up, right? Just alternating grain structure. Simple as that, okay? Now if I take two pieces, just two pieces, that have then been bonded together, still no curvature, but just two pieces, feel the stiffness on that. That's two pieces of wood that just now were doing that, but now they're put together, increase the stiffness. Now our smallest model of loudspeaker, the 805, is composed of 12 layers. Something as you can see here, which is a wood veneer. The inner is black, it's purely cosmetic. It just means if you look inside the loudspeaker, which guys like you are particularly keen to do, you'll see a nice, clean, consistent finish, okay? But as you can feel, now we're moving pretty stiff, right? You have a wood veneer, which is an American walnut wood veneer. Now our wood veneers are what we call matched, book matched, left to right. So if I can take those two veneers, you can see they match completely to the left and the right loudspeaker. That's why we refer to it as book matched, like that, like a book. So that means the veneer products, they travel around the factory in pairs, all the way around. The painted products, they're singles, right up to the point when we pack them. And at that point, that's when they become a pair with serial numbers. What that also means is if you go around the factory, you may occasionally see one of these guys with a circle on the side that says GB. Now that's not us being nationalistic in Great Britain. What that simply means is we're going to rework that loudspeaker into a gloss pack loudspeaker. Because if one of these veneers gets damaged, they're both damaged. Because they're a matching pair. It doesn't mean going in the trash, it just means rework. Alright guys, we're going to... Then you've got a combination of heat and obviously a huge amount of power for the forming press. So these are heated up to 90 degrees inside here, and then the amount of power that goes in varies with the size of the tool. The big guy over here on the right hand side, 80 tons vertical, 60 tons horizontal. And they sit in there for a period of time, which depends on the numbers of layers and the construction. It varies between around 16 minutes in the small guy to about 23 minutes in the large guy. You can see the blue here. Steve, have you got one hot off the press?
This will be 20 minutes. If you're sitting in the area, I'll pop you when it comes out.
Is anyone sitting out long?
They just take.
So guys, right, you can see right here are the fronts and the tops. So remember I spoke to you before about the tops, and you can see clearly they're thicker pieces. Take one out right here.
So this has come out of the press?
That's cool now, because you can see it's got a fan running over the top of it to cool it off down. But you feel the weight? Yeah? What you have to be real careful of here, guys, is the edges. Until this is machined away. Okay, so perfect example, right? The CNC has just completed some of its tasks. So if you look, right now we're mid-cycle, and the tool CNC cutter, which is what's called a 5-axis. So it can work in multiple different planes and multiple different parts. It's in the process of going to a cycle and change. The guys have also got something here set up, ready for the next fit, ready for something else to go in. Now there are two things really important. If you're cutting wood with a blunt tool, then you don't get a very sharp cut. So those tools have to be moderated and checked and monitored constantly for sharpness. So you can see right here one of those rough cabinets that I referred to before, and this is one of the machine ones. Okay? Now this structure has to go together completely, and every joint has to have full and perfect contact throughout the entire structure with every other part of the joint. If at any point it doesn't, then what we've created is essentially like a cracked egg. It means it's got a weak point. And I said to you earlier on, the really important point about this is we want it to be stiff. We want it to be inert so it doesn't vibrate, so it doesn't make noise. It's the exact inverse of a musical instrument, the context. So unlike a guitar or a cello, with the volume, the vibrations, the sound is a benefit. In a loudspeaker, this has to disappear completely. So how precise these joints are is A1 important. How well they fit together is A1 important. Because when they're all together like an egg, they're reinforcing each other in all directions. The other thing is it has to be sealed acoustically. If it has a small hole in it, it doesn't sound right, we've got a pressure leak. So again, we're talking about two things, structural and acoustic sealing. So that's why all these joints are measured, that's why all these fits are really important. And when everything comes together, we've got a completely strong and reinforcing structure. And you can see right here, guys, how, as I said to you earlier on, the wood ones travel around as pairs. These are all paired up. And there's a GB, that's a rework. So the matrix assembly is this. You saw the machine slots that I showed you just now on the inside face of that 800 series loudspeaker. These curvatures fit into those machine slots. Doing this is actually stiffer than metal because of creating a composite. We've got aluminium with ply with aluminium. If it was the same thickness of just aluminium, it wouldn't be as stiff as this is. The second thing is, actually we're talking about putting a wooden component inside a wooden component. If you took a metal component and you put it inside a wooden component, over time the two things would drift and shift because wood's a natural material. We have to make sure that this moves in complete sympathy with anything that it's connected to. So if your loudspeaker in 15 years time is maybe 0.3 or 0.4% smaller than it was when we first made it, this will have moved with it to compensate. So it's always going to work. Now, if you look at the back panel here, that's the back panel here. This, acoustically, is the back of the loudspeaker. This space that we have here creates what we call a pocket or a void space that we can use to house our crossover components in. So in a larger models of loudspeaker, this is where essentially the brain of the speaker lives, in this space. Now if I can ask you just to turn right round, guys, you can see the tool over here. Sorry. Okay? Mark, let me take your camera 1 second. I just want to ask you to do one thing. Just try and pry that apart.
Oh yeah. Love to. As hard as I can?
Yep.
Wow.
Yeah?
Strong.
So at the moment, it's an unsupported structure. It's literally just a bent bit of wood, right? But it's real stiff, right? You'll vouch for that.
Absolutely. Vouch.
What we're then going to do is stiffen it up a whole ton more. By the time we put in at the bottom, the matrix assembly at the top, and then glue the whole thing together, it's going to become that massively stiff structure that we were talking about. Now at this point now, post that, this is one structure. So if we've got any problems now, the whole thing's done. There's a huge amount of pressure coming onto the side of this wood right here. What we want later on is when the customer runs their finger down the side of that seam, they get a nice consistent transition from the wood to the metal of the crossover component. So we put this in now to make sure that we can't over compress the wood. This is basically making sure that we're providing a nice clean, what's called step, between the metal component and the wooden component. And later on, when we see production loudspeakers, we can try it. We can find the fit spot on. Okay? This is the sounding workshop. Two important parts of the process here. The first thing is after you've assembled a cabinet in the first instance. So if you see that white cabinet right there, guys, you can see the rough edge across the top where it meets the bottom part of the cabinet. That is before any paint application. So that's white paper and it's literally been bonded together. So what we need to do in the particular case of that one is sand it and prep it to get it smooth, ready for it to then receive paint. What we then do after we apply paint is bring them back here again to be smoothed further to receive more applications of paint. So this right here is the stoving oven, and as you can see, essentially almost laid out like a ghost train. So loudspeaker is going to run through a stoving oven for about 44-45 minutes, obviously being heated as it goes. You can see that those platforms allow the speaker to naturally rotate. So it's like a rotisserie, literally like a chicken in an oven. It's just generally getting evenly cooked all the way through as it moves around the steady train. So 4 cycles for a black loudspeaker, in each cycle about 44-45 minutes, and each one as it emerges back into free air, it's being cleaned as it moves through before it goes back into the paint assembly to receive more paint. Robot painter. Then we have to stop, clean the chamber down, clean all the injectors, clean the lines, clean the nozzles, get everything ready, please. And obviously take care of making sure that we're ready for the next cycle. Of course, why do that? Well, of course, you get a tiny particle of white paint and black paint, you can probably get away with it. A tiny particle of black paint and white paint, you're done for. You're painted grey. So everything has to be cleaned down between cycles. That also explains, by the way guys, why we only offer a relatively small number of standard finishes. When you're making speakers in this quantity and using this process, and you talk about all the other processes as well, if you magnified that over 15 or 16 different finishes, you'd be requiring a hell of a lot of paint savings. So we offer the standard finishes that you can see, and essentially if the customer really specifically wants a bespoke finish, we can address that, but we charge an additional premium for it. We only do it very rarely, and it's all done by hand. So, it's produced for us up the road. It's produced in Ascot in the UK by a company called L6, so part of the De Beers Group, the De Beers Diamond Group. And it's basically industrial diamond, which is then reprocessed using a process called CVD, chemical vapor deposition, into this. So what happens? You take a substrate, which is the shape or form of a diamond, which is one of these, of the dome, and you put it in the bottom of a chamber. And then you highly pressurize and highly heat the chamber. I'm talking to volcanic temperatures. Then you inject a gaseous cloud of diamond particles. Now those diamond particles are essentially formed from the byproducts of what they also do at part of the De Beers Group. If you think about the work that they're doing, they're producing things like industrial grade diamond tips for deep sea oil drills. So machining those away creates very fine particles that very easily are then usable for the process that we're working towards. So that gaseous cloud is injected into the top of the chamber. Then gradually reduce the temperature and reduce the pressure inside the chamber, and the gaseous cloud begins to descend. And as it descends, it forms a very fine membrane, almost like a frost, over the top surface of the substrate. And that frost is, you just saw there, 40 micron thin, so basically a few human hair, not very much at all. Then we do acid erode away this, and we're left with the dome. Laser cut the edge of it, and it is in fact completely artificially grown, real diamond. It's not just diamond for the sake of it. Now why do it? What's the premise? Again, you guys are audio guys, so I can hopefully talk numbers to you, okay? Upper frequency of human hearing in an adult male, especially a younger adult male, is probably approaching 20 kilohertz. For an older male like me, probably about 16 kilohertz, 16,000 cycles per second, right? Now, if you design a system to just meet that number, what happens when you get close to that number? Let's say you design a car that could only do 100 miles an hour, and then you try to drive it at 99. What's going to happen? The car's going to start to become pretty uncomfortable, right? Steering's going to start to feel a bit snaky, the engine's screaming, everything's sounding stressed, because you're right on the limits of what that car can do, because it can only do 100. Now if we design a tweeter, which is one of these, to just hit the limit of what you can hear, what happens when it gets close to what you can hear? It starts to do the same thing, it starts to enter stress limits, it starts to distort. So we don't do that, we do the reverse. We design a system that can go way beyond the threshold point of what you can hear. If you think about this in car terms, this is a Bugatti Veyron, right, or a McLaren Senna. It's so far away from any stress limits that it's not even going to get close to it. You're now cruising at a 250 mile an hour car, but you're doing 50. And it's just going, yeah, right, okay, it's relaxed. This is exactly the same principle for us. So, our diamond dome goes up to 70 kilohertz, in fact slightly higher, 72 kilohertz, more than 3 times beyond the threshold of what you can hear. And that means in the area where you can hear, it's nowhere near a stress limit, which means it's behaving perfectly.
What's the first breakup?
72. Yeah. So that means we get very clean response. That means we get zero distortion in the audible range, which means we get lots of detail, lots of resolution, lots of accuracy, all things that we're trying to chase. I mean, distortion fundamentally is literal, and you guys know that, right? A drive unit starts to bend and flex and go out of shape, it's distorted. It means the sound is distorted as well. It's pretty obvious. So, a lot of work on that. As I say, our IP, our work, we do it in conjunction with Element 6 simply because we don't have the manufacturing capability to build it here, but we control the ownership of it. And it's shared with them. Okay? So they supply the domes to us like this. As you can see, there are multiples from here. The parts cost of this is quite considerable, so it's a technology that we can't deploy on every single product. We preserve it for our premium products. You don't get it in the 600 series, fairly opposite. And then we go through everything else, the assembly wise here as well. So we're taking the dome, taking the voice coil, that's the copper coil, that's the dome, putting them together. Sorry guys, turn it around, see that okay? And it's still pretty low mass. Jen, can you palm your hand? Put that one. Pretty light, right?
Oh yeah.
Again, making it super stiff is one thing, but if it became super heavy, something's got to make it move. Then it requires more energy to make it move. So we need to make it light at the same time, right? It's inside that gap, and then it sits inside a little bathtub. And that little bathtub is ferrofluid, which is magnetic cooling fluid. So as you can see, it's a liquid. So move it around, you can see it's a liquid. But then if I stick a magnet on it, it follows the magnet. So ferrofluid sits in the gap, it's retained in place by the magnet, and then it means the coil is constantly kept cool by the ferrofluid.
Wow.
Now why is that important? Because heat generates distortion, it also generates stress on the assembly. So we also want to make sure that we don't stress it in other regards as well. So the back, that's the front, the back is bolted directly to that. That is the solid body tweeter assembly, you'll be familiar with that I'm sure by now guys. So this is taking any remaining residual heat and it's going straight into a massive aluminium heat sink, which is this. This never gets hot, trust me. There's not enough heat to do that. But the point is we're dispersing any remaining energy here. And that's just great news for the life cycle of your tweeter. This means it's going to last a lot longer. If this blows up now, you're trying really, really, really hard. Okay? Solid body tweeter assembly comes from one of those. So it's milled from solid. We do this work overseas. It comes to us as a supplied part like this, but raw. We paint it on site. But it actually originally comes from one of those. So this is that. So this goes right back to that question I'm going to give it to you again. Why is it that we don't make the whole loudspeaker out of metal? Why do we make it out of other component parts? Well, you can feel the mass of that, right?
Yeah.
And if you imagine trying to machine away a loudspeaker that was this big out of that, you'd wind up with like a 450-pound weight loudspeaker. And it begins to interact with it. Now, in a wider loudspeaker, that would mean some of the sound would travel along the edges before going forward into the room. And we get a coloration effect caused by the cabinet. Now, what does a coloration effect mean? I'll put myself inside a loudspeaker cabinet. This is me inside a loudspeaker cabinet. Can you hear a coloration effect? Yeah. Right? I take myself away and it's gone again. That's what that means, yeah? This is what a loudspeaker cabinet does to a loudspeaker drive unit. Make sense?
Yeah.
So what we do with a bigger drive unit is we try and get the edges of the cabinet as close as we can to the edges of the main drive unit. That's why the majority of modern loudspeakers now have got a lot slimmer. There's nothing to do with fashion, it's just about acoustics. Well, what happens when you get to this? With a bigger box loudspeaker with a regular cabinet tweeter, it'll be sitting right in the middle of the box, which means you're going to get some of that effect. So what we do with the tweeter on top, and what we've done now since 1974, is put it into its own separated enclosure. So we're really maximising the amount of energy that we get from that whole process. So instead of wasting sound travelling along the box, it's just blasting it forward into free space, which means we get a much more effective dispersion. Okay? Also, Joe, driving a digital car for me, mate. There you go. Sit in most cars like this, right? You've got a windscreen like this, you've got a dashboard like that, right? The tweeter is sitting here, bouncing up some of the sound off the windscreen, and then the sound's going to your ears. You go in a McLaren or a Volvo, the tweeter is in a tweeter on top, and it's doing that instead, it's working straight at you. Amazing the difference that makes, right? That's real simple. That's why we do it. That's right. The fundamental premise about how a loudspeaker operates really hasn't changed over time. What we're trying to do is do the same job that anybody else can do, but we're just trying to do it better. So we're trying to completely optimise the whole assembly, the whole system, and we're trying to use the highest performance componentry that we can. The majority of regular loudspeakers are going to use something like this, a standard ferrite magnet. Pretty heavy, got a fair amount of power to it. Some of our more affordable loudspeaker models will use something like this as well. You find something like this in a 606 in the mid-bass drive unit area, and it's got a fair amount of power. If you're going to take that one off, you'll find it's pretty easy, please. Yeah, not a big problem. Fair amount of shelf to it. This is not the kind of thing that you use in a premium loudspeaker. In a premium loudspeaker, you use neodymium, rare earth magnets, so significantly more horsepower. So, compared to that, we're using something like this, and that's quite a substantial neo. If you go across all of our main loudspeaker ranges, 600, 700 and 800, we use neodymium on all the tweeters, and then on 700 series we introduce it on the mid-range, and on 800 series it's on everything, full neo motors. So that's the neo magnet. Compared to the one that you just held, it's pretty light, right? That isn't coming apart. There is no way. Have a feel?
Yep.
Okay?
Yeah.
Now, rare earth obviously means it's deep mines. Most of the majority of neodymium supply these days is held in China. Why use it? Extremely linear, much more powerful for each mass that we're using. Very clean, very low distortion, and it's also lighter, which means we take away some critical top weight from some of our loudspeakers. You can think about a lot of the larger models, like critical top weight up here. Most loudspeakers have to pass what's called tilt test compliance, where they go beyond a certain point and they fall, you have a problem from the point of view of home safety. So the less weight we can have at the top is probably a good thing. But the most important part is performance. Go back to the point. You've got that super stiff cone, you've got that cone moving. You need to stop and start that cone with real precision. The more muscle you have in your motor, the more precision and control you have over how that cone moves. So Joe, like this, not like that, okay? Ready? Got it? Have another message. I'll try and take it off.
Oh my god.
Yeah.
Good job.
There's a technique.
Yeah, you have to roll them to the side, it's the only way. From that point of fitting it, it'll be lifted by the air handler, which we'll go into in just a moment, put onto its back, and then move forward on to the start of the production line. And from there we go. Now people say again, how long does it take to make a loudspeaker? A final product assembly line, one of these, could be able to make as many as 45 loudspeakers in a single day. So a couple hours, max, per speaker, max, and in some cases less. But of course, all the work that's gone into creating all the steps and sub-assemblies up until that point can take, as I said to you earlier on, as long as 3 weeks. Okay. That's working on compressed air, basically suctioning onto the side of the product. It's called a pneumatic handler, and then it just lifts it without adding any touch to the product, any marks to the product, allows us to put it down into the packaging pristine and clean. Take a look inside now. You can see port tube length inside the assembly. You can see that metal plate that we referred to earlier on, bolted onto the inside face of the loudspeaker. Now in just a moment, we're going to fit some pods to here that allow us to mount the drive units in position. But if you remember how we spoke about how things working in composite somehow work better, we're going to take a metal pod and then we're going to bond it through the wood to that aluminium plate, and then we're going to couple it up real tight. And as a result, we get another composite structure right in the front of the system. And then we put the drive units into that housing and rigidly coupled to that. So all of that vibrational energy is then being transferred directly into the heart of the loudspeaker. So these right here are going to fit through in these mounting points. As I said, base drive units are then going to go in place. Okay? Now they come in different sizes that correlate to different sizes of drive unit. This one right here is for an 800. This one right here is for an 803. Simple question. If you imagine if it was a perfect circle, we mentioned before how the drive unit does that and then it does that. On the recovery phase, if it had a perfect circle, it would have a perfect edge to generate a pressure wave off. Basically, we'd be generating a sound within the loudspeaker reflecting off that inside face. So using this eccentric machining, we generate essentially our own diffuser inside the loudspeaker to reduce noise in the drive unit's recovery phase. Next question, why are they different sizes on different pods? The bigger drive unit moves less than the smaller one. This is the one from an 800, so to generate the same sound, it's moving a lot less than one of these. So this needs more. It's as simple as that. It's all subsurface technology that the customer never sees, but we quite like it. Okay? checking from the side, right? The turbine like you see underneath the wing. Minimising the overall size of the outer shape makes it stiffer. Making it of aluminium makes it stiffer. Bracing it critically internally with that turbine system makes it stiffer. Making it stiffer pushes the resonant frequencies up. So taking it up to a certain point and narrowing them down, when you hit it, it doesn't ring. Its mass weighs 18 kilograms. And that then has to sit on the top of the loudspeaker. And it sits on this, and these are more isolators. Again, these are TPE. So this is a compliant, compressible material. The head assembly sits on top and compresses into these. Not so much though that the head assembly actually makes contact with the top of the loudspeaker. If you look at the loudspeaker behind you, you can see it's really important that we have the ability to hold them slightly float. Yeah? But because that's heavy, if it was too heavy and these compress too much, pardon me, this would actually be making contact with the top of the loudspeaker. It's been measured and tested. What we're now doing is measuring the complete loudspeaker. And that's against the reference data, reference measurement data. So we put an impulse sweep, low sounds up to high sounds, all the way up. Measure the response, loudspeaker passes, it moves on. If it fails for whatever reason, and it shouldn't happen, but anything can happen, then we can take it away, we can test it, we can put it back in and fix the problems. Once it's passed, and not before, then all of its serial number detail will be attached to the product. So it only leaves after it's passed. You can't get its serial number attached to it until it's passed. Okay?
Thanks for watching. If you like this video, give it a thumbs up, leave a comment, and be sure to subscribe to this channel.